Hello everyone, I'm Trinh, Senior Application Engineer for Valin Corporation. Today I will illustrate how to connect between the Mitsubishi PLC to communicate to an IAI RCON Gateway Controller using CC-Link Field Network. Having said that, so what I have here for the setup is that I have a Mitsubishi PLC. The CPU model I have is R04 EN-CPU, and I have a power supply, an IAI power supply in here. And that is IA-1059 PSA24L. I have an IAI RCON Gateway Controller for CC-Link Field Network, and the part number is RCON-GW-CIE-ET. This particular one has an extra Ethernet port on here, so I can connect to the RCON via USB or Ethernet. And then I have next to it is an RCON-BC-2, and this happens to have two ports that allows me to connect two different actuators from IAI. And the actuator I have here for this illustration is an IAI RCP6-TA6C-WA-40-200-P3-P-CJT. And basically, it's an actuator with a 200 millimeter stroke with an absolute barrierless encoder in the back. So if I go further here, so you can see the cable. So this cable coming out the back of the actuator has the power cable, the encoder cable, and that's basically connected to this port right here of the RCON controller. All right. I have an extra port here that allow me to connect to a second actuator. Okay. And so what I have here is, you see this cable here, that's an RJ45 cable, and that basically connected to the CC-Link port on the CPU itself, which is this port right here on the Mitsubishi PLC. Over here, I need to supply 24 volt power to the connector here. And up here, I need to supply 24 volt power supply as well to it. There's some jumper here, and that's for safety. I just jumper it for now. Same thing over here. So that's basically the setup that I have. So on this side, what you see here is basically the Mitsubishi development software. It's the MailSoft GX Works 3. Okay. And what I have here is basically the register that I'm using that allow me to turn on the servo, to home the servo, to home the actuator, to jog the actuator forward, backward, as well as commanding it to go to a certain position with a desired speed as well as acceleration that I wanted to. Okay? So, let me show you this mapping real quick. Okay. So what you see here is the mapping for the CC-Link actuator, the very first axis. So the first two registers are used for setting up the position that you want the actuator to go to, and it's in the unit of 0.1 millimeter. The second two registers here are for setting up the position width. The fifth register here is for the speed, and the unit here is basically 0.1 millimeter per second. So if I put in 1,000, then that means it's 100 0.0 millimeter per second. Going back to the position data here, if I put in 10,000, that means it's 100 millimeter that I want to go to. If I want to program 150.55 millimeter, then I would put in 15555 for 155 millimeter point 155.55 millimeter, and we'll go through that. That cell in this cell is basically 0.1 G unit. So if I put 3 there, that means it's 0.3 G. I can also program the push current limit here if I want to. For this illustration, I'm not going to do that. Last but not least, the last registers here basically consist of all the bits that you need to control the actuator. For example, there's a S on bit here. That's basically a servo on bit. I can home the actuator using this bit home here. Now, because the actuator, the RCP6 actuator, has a batteryless absolute encoder, you don't need to home it because it will retain the position even after you lose the power. You may want to do this when you first set it up the very first time, but that's it. Okay, which is a very nice thing about the batteryless absolute encoder feature on these actuators. Okay, you can also jog forward, which is jog plus here, or jog minus the other way. Okay, if something wrong with the controller and you want to have the reset, there's a reset bit here as well, which is the RES bit here. Okay, now once you program the position width, the speed, and the XL and decel that you want to go to, all you need to do is flip this bit, DSTR, it will command the actuator to go to the position that you specify here. Okay, so that's basically the memory map. Okay, let's get back to the GX works here and also the camera so you can see how it works. So right now the actuator is not at home. Okay, and it's probably servo on right now. Yeah, it's already locked it. But let me show you how that works. Let me fill in the status as well. That way you will see all of them. So the status words are from W150 to W157. And how do I know that? I'll show you. You basically configure where the register you want it to be. I just arbitrarily set up these registers. Okay. All right. So from W100 to W107, those are RWW, meaning the register that I'm writing from Mitsubishi to the IACON to tell it the position width, the speed XL, and also command it to go. Okay, so these are the bits right here. Okay, I'm gonna turn it off here. I'm gonna turn the servo off so you can see that I can move the actuator freely by hand now. See, I can move them, right? So let's say I want it there. Okay, now if I turn on the servo, which is this bit here, now it is on. So it locks wherever the position is, which is great. At this point, let's say I want to home the servo or actuator. I flip this bit here, bit 1. Okay, I'm going to turn it on. As soon as I do that, the actuator will retract and go wherever the home is and establish the home position. Here we go. There you go. So it's going home. And I know it because if I look at here, this is my current position. Right now it's at 0. Okay, great. Let's say I want to jog this actuator. So the bit to jog it is this bit right here. So I'm going to jog it forward. As soon as I press 1 here, the actuator will move forward. Here we go. Voila. Okay. And it just happened that the actuator here is 200 millimeter stroke. So that's why you got 200 millimeter 0.1. Okay. Now, let's say I want to jog it backward, which is this bit here. As soon as I do that, it will retract and move back. Okay. So that's how you can jog forward, jog backward. So let's say at this point, I want to program distance, a stroke that I want to go to. I'm going to program 155.55. 155.55 millimeter. Okay. And the speed I want is 100.0 millimeter per second. That's why I put 1000 here. Now, all I need to do is to flip the bit 0. So let me turn off all this first. I'm going to flip the first bit here, which is the bit to tell. Actually, I need 0, enter. This guy, I don't want a home, so 0. Now I'm going to turn on the very first bit 0, which is this. So as soon as I do that, the actuator will go to 155.55 millimeter, and you will see the update for the current position will be updated here. Okay, let's go. All right, it's going, and voila. The actuator now is at 155.55 millimeter. Okay, so that's how the mapping works. Let's say I want to go back 1078. That means 10.78 millimeter. Okay, which is somewhere around here. I'm going to execute it now. Again, you need to turn this bit off first and then turn it back on. That's why it's going to see the leading edge. Okay, here we go. It's going back, and voila. The current position now is at 10.78 millimeter. All right. So how do we set this all up in the Mitsubishi PLC? First and foremost, you need to grab we can send you a CC-Link file so you can configure. And to do that in Mitsubishi, you click Tool, you select Profile, Management, and you click Register, and then you point it to where the file is. I already do that, so I'm not going to do that. But you basically point it where you save the files in your computer, the folder, and then it will take care of that for you. Once you've done that, then you need to configure the CPU, the CC-Link. So what you do is you click this and you click the RON, the RO4EN CPU, and then you click the module information here. And this is my CC-Link master here. That's what I need to select. If you have different Mitsubishi CPU, then it may be different, but this is what I need to go in and configure. So I'm going to double click on that. So it's launching the configuration for the CC-Link. Now, the required setting, you need to make sure that you change this to master station. By default, it won't be master station. So make sure you change that to master station. The network number is 1. The station number 0. And then you want to go to the basic setting, and under network configuration setting, right now it's in the detail setting for the network configuration setting, and for the refresh settings is in black color. Why? Because I already configured. Otherwise, it's going to be in blue, by the way. So I'm going to go in and show you here. So it's launching another Windows. Voila. So under here, if you click on the general CC space IE dash view module, expand that, you will see a general intelligent device. So you want to select, press and hold that and drag it over here. I already done that. So that's why it's here. Once you drag it over here, it will display under this window general intelligent device station. Okay, station 1. That's what we want. Then you go in here and you specify the start and end for the RX and RY, and also for RWW/RWR. Okay? Because I have 2 axes, right? Because this RCON-PC-2 support 2 axes, and I know earlier that I show you each axis has 7 words or 7 register. 8 words, 8 register, or 8 points. In this case, they call it times 2. So that's 16. Okay. So that's why the 16 is here. All right. So you put in the star 0, right? And then the end would be F. Okay. So that's for the RWW and RWR. The RX and RY, this is what you need to put in. Okay, 128 points. So you put in 0 here, and then you put N7F. Once you've done that, what you need to do next is to go to the network, refresh settings here. Okay, and this is where you will map it to exactly where you want it to be. I just arbitrarily select RWW to be the device memory W, and I start at 100. So the end would be 10F because I got 16 of them. Same thing for the RWR. I need to select 16 of them. So again, I select device memory W. The address beginning of that is 150. And I need 16 of them. That's why it's 15F. And it's matching exactly what you saw earlier when I show you the watching window. Here. Right? W100 to W107. That's writing register. W150 to W157. Those are reading register from the RCON to the Mitsubishi. All right. So that's basically it. How to set up the communications between Mitsubishi PLC that supports CC-Link Master to communicate to an IAI RCON Gateway with CC-Link Fuel Network. Thank you for watching. If you have any questions, please call the number below. And thank you.